The Standard Model is a theory created in the latter half of the 20th century concerning the electromagnetic interactions and the weak and strong nuclear interactions. This theory also classifies all known subatomic particles, but it fails to explain some phenomena like gravity. Quarks are elementary particles that make up matter. There are 6 flavors. There's the up, down, strange, charm, top, and bottom. Each quark has an antiquark with the opposite charge and color charge. Quarks combine to form composite particles called hadrons. Hadrons must have a neutral color charge. This, for example, is a neutron. In order for the hadrons to have a neutral color charge, the color charges of each of the quarks making up the hadron cancel each other out. There are 2 types of hadron: baryons made of 3 quarks, for example, proton and a neutron, and mesons made of 1 quark and 1 antiquark. In composite particles, the charges of the quarks combine to make the charge of the particle, which is always an integer. The weak interaction is caused by emission or absorption of W or Z bosons. These bosons allow quarks to swap flavor, changing the property of the particle they make up. For example, in beta minus decay, a down quark decays into an up quark, converting a neutron to a proton. So if this down quark turns into an up quark, this particle, this hadron, is now a proton with a charge of +1.
Now for the difference between leptons and hadrons. It is in fact quite simple. Leptons are only a single particle, such as an electron. They have integer charge and are unable to form composite particles. Hadrons are any particle which is made up of multiple quarks. For example, this friendly proton up here. Both of these items have integer charges, and both are affected by the 3 fundamental interactions: gravitation, electromagnetism, although that does not affect neutrinos, the alternate variety of leptons, due to their lack of a charge, and the weak interaction. Finally, we move on to muons. Muons are negatively charged fundamental particles that have a lifetime of just 2.2 microseconds. Although this is huge by the standard of unstable subatomic particles, it is still a tiny amount of time. They are leptons, so have no known subparticles and are unaffected by the strong nuclear force. When they decay, they split into an electron of equal negative charge and 2 neutrinos. On the other hand, we have neutrinos, which are uncharged leptons, and as such are only susceptible to the weak nuclear force and gravity. They are largely unaffected by anything they pass through. Should they hit matter, they go through because they are unaffected by the electromagnetic force or any other interaction with the mass. Because of their lack of interaction, they are very hard to detect.